this, look, if you look at the question, so there are 5 this, so there are 3 evens, right? 3 evens. Then this is without replacement, it's clearly mentioned. So we need 2 evens and 1 odd. So when we took the first even, this is 3 over 5, the other even would be 2 over 4, right?
Yes.
Then we would be selecting one odd. There are how many odds? 2 odds. But how many? We have already selected 2. So there would be one more reduction. And how many groupings can be made? Well, there are 2 evens. So 2 of the
Oh,
same.
wait,
3 times,
I
right?
made a calculation error.
Okay.
So yeah, it is 3 over 5.
Yeah, that's what I was thinking. So the final answer is 3 over 5. Okay, now for part 2. Let's find this. Okay, so now they are saying the smallest of the numbers on the 3 disk. On the 3 disk is denoted by the random variable s, RVS. By listing all the possible selections 1, 2, 6, comma 2, 4, 6, draw up a probability distribution table, right? So you have to make a PD for this. Okay, if you recall, if you look over here, so you would say, okay, possible selections. For example, if the number is, and you're taking the smallest of the numbers on the 3 disk is taken, right? So let's arrange them. For example, the first they have given, right? So it could be 1, 2, 4. Which one is the smallest among the 3 numbers? 1, right?
1.
So our S, first of all, you will be determining the S, right? Okay, so the first would be the smallest is 1. So S, P of S. So 1. So how many outcomes are possible? For example, these all are different. So 6. Okay. Then 1, 2, 6. All are different. 6. Okay.
Yeah.
7. Then again 6. Then the possibilities could be 1, 4, 6, right? 1, 4, 7, 6, 6, right? Or we can simply do, since all of the 3 outcomes, just listen carefully. If the 3 outcomes, all of them are different in each type, so instead of writing 6 and making our things life complicated, we can just erase this notion and we can just count the individual items because all of them have the same multiple, right? We can do that, right? For example, the number of outcomes we can make first and then we will proceed forward. Okay. So 146, then we have 147, then we have 167, right? So these are the possible outcomes for 6. Oh, sorry, for 1. When 1 is the smallest number. Okay. So if 1 is the smallest number over here, how many outcomes are there? There are 6 outcomes in total. And if you want to multiply, because each one is having 6 outcomes, because all are different numbers, so you can multiply them by 6 as well. Okay. For others, now there is a possibility that the outcomes could be like the one they have written 246. So 246, 267, right? For 2 there are how many possibilities, and other could be what? 247. Is there any other
Yeah.
possibility for 2?
2, 4, 1.
But again, 1 would be the smallest, na? Because 1 is smaller than 2.
Uh, right.
Okay. So now for 4, only one possibility, 4, 6, 7, or 6 possibilities in your terms, right? So now since you have calculated, right? So what we will be saying, 1, 2, 3, 4. How many are there? These are 6, 7, 8, 9, 10. 10 outcomes and the possibility, since S is the smallest number, one is 1, the other is 2, and the other is 4. Okay. Probability of 1, we can do it either way. If you want to multiply each one of them by 6, then that would be different number of outcomes. Or if you want to just keep it this way, then this is simpler as well. That would be a simplified form, right? For example, out of these 10 outcomes, how many are coming 1? There are 6. How many for 2? There are 3. How many for 4? 1 upon 10. If you would have multiplied each one of them 6, the answer, the final proportion would be the same. Because we have a common multiplier, right? Is this part clear?